For vertical asymptotes, every time in the denominator, set it equal to 0 and solve. That's almost always going to require you to factor. The only reason why you wouldn't factor is because it's already factored out. But for this particular problem, we do have to factor. So I notice real quick that there's a GCF of 4, which I'm going to factor out. That's going to make my factoring a lot easier. So divide each one of these terms by 4, and I'm left with x squared plus 2x plus 1. Now I recognize that this is a perfect square because the only two numbers you can multiply together get 1 is 1 and 1 plus 1 gives me 2. So I know that this becomes x plus 1 times x plus 1. So that's the whole denominator set equal to 0. I'm going to take each term and set it equal to 0. I did not need that beginning parentheses right there. So I'm going to take the factors and set it equal to 0. And that's going to say minus 1 minus 1. That's going to give me x equal negative 1. So x equal negative 1, that's where my vertical asymptote is. So in this case right here, I'm going to write x equals negative 1. And of course, you see this button, the button right here that says no horizontal asymptote, no vertical asymptote. This one would be button. If you got bigger on top, you would have no asymptotes. You would click that. If you got bigger on bottom on that one, you would put 0 right there. The only reason you would get no vertical asymptote here is if we did not have an x in the denominator. And if we don't have x in the denominator, we don't really have a rational function. So you're almost, you're always going to get a vertical asymptote. And if you jump over here to Desmos and you see this is the function that we're working with, we just factored that denominator and set it equal to 0, and we came out with x equals 1. And then I graphed x equals negative 1, and it shows very clearly that that is the vertical asymptote. Now, different from the horizontal asymptote, the vertical asymptote will always, always, always be a true asymptote. True asymptote meaning that the graph will never cross that. And that's also still the way we find our domain. If we have a vertical asymptote, that number cannot be in the domain. So if I ask you what the domain of this function is, you would say x cannot equal negative 1. Or you would do the interval notations with the union. Negative infinity to negative 1 unioned with negative 1 to positive infinity. All right, so that's how you find your vertical asymptote. You set your denominator equal to 0 and then solve. Usually involves first step of factoring. Now finding the x-intercept, it's very, very similar to finding the vertical asymptote. We're going to take the numerator and we're going to set it equal to 0 and solve. So over here, I have written the numerator, 3x squared minus 9x minus 12. I'm going to set it equal to 0 and I'm going to solve. What are we going to do? Factor out the GCF. I notice there's a 3. That's a common factor to all of them. So 9 divided by 3 is 3. 12 divided by 3 is 4. Now I'm going to, this is just going to be an easy trinomial. So all I have to do is find two numbers that multiply together to give me 4. That's subtract, because that's a minus. Multiply together to give you 4. That's subtract to give you 3. Well, that's easy. That's 4 times 1. So I'm going to have 3, and then I'm going to have 2 binomials. One binomial is going to have an x and an x. One binomial is going to have a plus and a minus, because that number has to be negative. So only way I can get a negative value, this right here is a negative. The only way I can get a negative value is to have positive times a negative. So I need a 4 and a 1. I need to be sure and make the 4, the bigger number, negative, so that I'll end up with a negative 3. So I'm going to make that plus 1, negative 4. Set each factor equal to 0 and solve. So this will be x equal -1, and this will be x equal to +4. You'd add 4 to both sides. Add 4 here, you'd -1, -1. So your x-intercept. Now, did you notice that I got an x-intercept over here? That was where my asymptote was. My asymptote is at x equals -1. So this this 0 is not really this x-intercept is not really an x-intercept. I'm going to explain that a little bit later when I get down here to holes, but for right now, when we're writing our stuff in right here, you are not going to type in the -1 because we've already set it as our asymptote. So it can't be both an asymptote and an x-intercept on this function, because we could see that. It'll make sense in just a minute what happens to the -1, but again, I've got to talk to you about the hole. So we'll get there in just a second. So this one, this x-intercept right here, we're going to put at 4. And I believe if we jump over here real quick and we trace this function, here we're tracing it so you can see the x and y values right there. We see, well, we can just click it. There's the value of the x-intercept right there at 4. We see that over here at -1, like I said, that's where the asymptote is. So we're not going to list that as an x-intercept. Okay, the y-intercept is the last thing that I'm going to do on this video because the whole video will take a little bit longer. So the y-intercept is pretty straightforward. Let me get a new color. Let's do this purple. So the y-intercept is going to be, you simply plug in 0 for x and evaluate. That's all you do. So you're going to just plug in, you're going to say 3 times 0 squared minus 9 times 0 minus 12 over 4 times 0 squared plus 8 times 0 plus 4. Of course, that's going to give you 0, that's going to give you 0, that's going to give you 0, that's going to give you 0. So it's really just those two constants simplified, and -12 divided by 4 is -3. So your y-intercept is going to be at 0, 3. And that's the way you're going to do it every time. It doesn't matter if these terms up here are factored or they look like these right here where they're not factored. I mean, where they are factored, you just plug in 0 for x, and then you may have to like square the 4 and multiply it times 3. You still, to find the y-intercept, you literally plug in zeros for x and evaluate, solve it, simplify it. Let's jump over here real quick and look and see if we can see. There it is right there at 0, -3. Okay, so, I did forget the -3. I wrote the -3 right there, but I didn't put it right there. So, I'm going to stop this video now and do the next one for holes. Be sure you're getting this part memorized. Boba Botaniques DC is how you find the horizontal asymptote. Set the denominator equal to 0 is how you find the vertical asymptote. Set the numerator equal to 0, that's how you find the x-intercept. Plug in 0 for x, that's how you found the y-intercept, and now I'm going to talk about the holes.